Okay, this is a brief overview of reviewing chemical reactions, how to identify the type of reaction, how to briefly review how to make a compound using oxidation numbers, and then how to balance those reactions. So let's look. The 5 types of reactions are right here. You've got the synthesis reactions. This is where you're creating something. You have a variety of at least 2 or more reactants, and they combine to form one product. In a decomposition, you have one reactant that decomposes or breaks up into 2 or more products. In a single displacement, you have a reactant that is single. It's not bonded with anything unless it's one of the Brinkelhoff elements like oxygen or nitrogen, and then it's bonded with itself. But we're going to keep that as a single. And then you have a couple of some sort. It means you have a metal and a non-metal, or a metal and a polyatomic. Now if this is a metal, it's going to replace the metal. So X would replace A, and you would get an XB with A by itself. If it was a non-metal, then X would be in the B position, and so you would get A with X plus B by itself. So it just depends on if this is a metal or a non-metal as to how the products are going to work out. A double displacement, you have something combined with each other, an ionic compound, and another ionic compound. Now keep in mind that your cations need to stay the same. They're always going to stay at the beginning of those compounds. So X is going to be, instead of bonded with Y, X will be bonded with the anion. A is still a cation, so it's still first in the equation, and it will be bonded with Y. So it's going to look something like that. So double displacement is sort of like changing dance partners. Combustion is going to have some type of carbon-hydrogen compound. Mixed with oxygen, you may have other reactants, and you're going to get carbon dioxide and water, and you may have other products. But you're mainly looking at these oxygen creating a carbon dioxide and water, and that's going to give you combustion. Okay, let's go over some examples. Okay, now let's do some practicing balancing equations. Basically, when you're balancing equations, you want the same number of atoms of each type of atom on each side of the equation. You can think of this as a mathematical equation. So you want the same number of calciums, oxygens, manganese, and iodides. However many you have on this side, you also need to have on the other side of the equation. This is the law of conservation. Okay. You cannot create or destroy matter in a reaction. It's got to be conserved. So let's start with usually the more complex, and so I see a lot of I's here, so there's 4 iodines here. So since there's only 2 here, I'm going to add a coefficient. You always balance equations using coefficients. This is what's in front of each of the compounds. So you never mess with the subscripts. Those are not to be messed with. So I have 4 iodines here. 2 times 2 is 4 iodines. So my iodines are fine. I have 2 oxygens here. So I'm going to go ahead and put 2 in front of here. So I have 2 oxygens and 2 oxygens. So my oxygens are fine. I have 2 calciums here, and I happen to have 2 calciums here, so my calciums are fine. 1 manganese, and my manganese is fine. So I'm good. That's all I need. I don't put ones in front of compounds because it's sort of like in math. You don't put ones in front of x's or y's. You just say x. Let's go down to this one. All right, if you'll notice here, there are 2 irons on this side, but only 1 iron on this side. So I'm going to go ahead and put a 2 in front of that to give 2 of those. Keeping in mind this is a trial and error process, so sometimes you might put a coefficient and it messes up something else and you have to go back and rearrange things. That's okay. Just keep an eraser handy and you're good to go. An eraser is handy. So now I have 2 oxygens. No, I don't. I have 2 times 3 oxygens. So I actually have 6 oxygens here. Okay? I have 6 oxygen because there's 2 groups of 3. But I have 3 oxygens here, so I need 3 more right here to give 6 oxygens. So I have a 3 plus 3 oxygens gives me 6 oxygens. So my oxygens are equal. Let's look at a hydrogen. 3 times 2 is 6 hydrogens, and 2 times 3 is 6 hydrogens. So my ions are good, my oxygens are good, and my hydrogens are all equal. So I'm done. One more. This is a lot of iodines. There's 10 of them over here. So I'm going to kind of jump to the more complex thing and see that there's 10. So let me get that balanced out over here. I'm going to put 10 iodines here because I have 10 on this side. So now my iodines are good. Now I have 10 hydrogens. So that means I'm going to need 10 hydrogens over here. So my hydrogens are fine. But that gave me 10 fluorines. Well, when I go over here, I don't want to put a 10 in front of this. I want to put a 2 because 2 times 5 is 10. And that equals the number over here. So my fluorines are good. The last thing are my vanadiums. I have 2 of these and 2 of those. So they balance. So I'm good. Okay, now let's start putting everything all together and let's practice writing products, identifying reactions, and then balancing. So the first thing we'll do is identify the reaction type. Then we'll write our products. Okay. Then we'll balance with our coefficients. Okay. All right, so here I have a compound and a compound. So there's double and double. So probably they're going to switch partners. So this is a double displacement or double replacement reaction. That means I'm going to keep the cations in the front. Okay. And they're just going to switch partners. So hydrogen is not going to be partnered with nitrate or nitrate anymore. He's going to be partnered with hydroxide. One thing to know about hydrogen and hydroxide is when you put them together, you make something called water. Okay? Because this is an acid, this is a base, and you put them together, it makes neutral water. Okay, now iron is going to be mixed with nitrate. But you may not know how they're mixed together. What is this oxidation number of iron? Well, if you didn't have any information, you wouldn't be able to tell. But we do have information. This 3 came from the oxidation number of iron. This 1 down here came from the oxidation number of hydroxide. So you do know that this is actually iron 3. So now that I know that it's iron 3, I'm going to combine it with nitrate, which is a -1. And I'm going to crisscross and drop. And now I have my formula, and I'm good. Okay, so now let's balance. We've written our products. Let's balance. Okay, I'm going to look at my polyatomics as a whole. So I have 1 nitrate over here, and I have 3 nitrates over here. So I'm going to put a 3 in front of this. So 3 nitrates and 3 nitrates. I have 1 iron, 1 iron. Now let's look at our hydrogens that are by themselves. I have 3 hydrogens over here, plus 3 more hydrogens. That gives me 6. So I'll need to put a 3 here. 3 times 2 makes 6. So that gives me all my hydrogens. Now I'm going to look at my oxygens that are not part of nitrate because I've already balanced the nitrate. There's 3 oxygens here, and if you look at this, 3 oxygens are here. So I'm balanced. Let's look at the next one. Got lithium bromide with cobalt sulfite. Well, looks like 2 couples to me. So double replacement or double displacement. So lithium will stay as a cation and cobalt will stay as a cation. That's how you write those compounds. But lithium will now be with sulfite. Now lithium is a +1 charge looking at the periodic table. Sulfite is a negative. Let me double check that. -2. That's what I thought. Okay. So when you crisscross, okay, you're going to need 2 lithiums for every sulfite to get rid of all those electrons in that bond. Now let's look at cobalt. All right, cobalt, this 2 came from cobalt, so cobalt would have a +2, and sulfite, if you look at the way this is, would have a -1, but we know that's not right. You have to go to your periodic table and you see that sulfite actually has, as we just stated, a -2, which meant that cobalt must have had a +4 in order for this to balance out, this compound here. It was just simplified whenever they wrote it. So now I'm going to replace my anion with bromine, and bromine has a -1, okay, because that's its new partner. Okay, let's start balancing. It's time to balance. 2 lithiums. I'm going to put 2 lithiums here. 2 bromines. Uh-oh, what happened there? I need 4. This is why your eraser is handy. So let's put 4 bromines. Now my bromines are fine. 4 lithiums. I'll put a 2 right here. 2 times 2 makes 4. Okay. 1 cobalt. 1 cobalt. And then 2 sulfites. And look, 2 sulfites. So I'm good. All right, let's look at the next one. I have something here and something here, 2 things, 2 simple things. Well, I'm going to make myself something more complex. So this is a synthesis reaction. I'm going to make nitrogen monoxide. Well, I have 2 nitrogens and 2 oxygens. I'm going to put myself a coefficient of 2 in front of there, and I'm done. Last one. You've got a compound here, and then a polyatomic here. This has a polyatomic. These cations in the front are going to stay in the front, so I'm going to keep a hydrogen here, and I'm going to keep an ammonium here. This is a double displacement. Okay. Sulfate is going to be combined with ammonium. Ammonium on that polyatomic chart has a +1. Sulfate has a -2. So we're going to crisscross those and have 2 ammoniums, okay, for every sulfate. Remember, sulfate is not 4, that's just part of the polyatomic. All right, let's do the other one. I have hydrogen, which has a +1 charge, and hydroxide, which has a -1 charge. What do we know about HOH? We call it water. Okay, now let's do our balancing. There's 1 sulfate here and 1 sulfate here. There's 2 ammoniums, so I'll need 2 ammoniums. Okay, and then let's look at our O's. There's 2 oxygens here. That's not part of a sulfate. So I'll need 2 oxygens here. That's not part of a sulfate. The last thing to look at is our hydrogens. 2 times 2 is 4 hydrogens. That's not part of these. And we have 2 hydrogens here plus 2 more hydrogens over here, so there's 4 altogether, so you're balanced.